In this second lecture on automated mechanism design, we will see how to solve a problem with payments. We will start from the same problem of the last video, where a couple is getting divorced and an arbitrator has to decide who gets the ownership of a painting. So the data that we have are exactly the same as before. This time the arbitrator is self-interested and wants to maximize the sum of the payments she gets. Therefore, payments are possible. And moreover, we want a social choice function that is dominant strategy incentive compatible. The mechanism has to be deterministic and ex post individually rational. This time we look for two functions, an outcome selection function G and a payment function pi that associates payments to each pair of reported types. The problem can be modeled with the following formulation. Suppose the designer wants to maximize the sum of the payments she gets from the two players across all possible pairs of reported types. Notice that this makes sense since payments are always greater than or equal to 0. The first family of constraints enforces dominant strategy incentive compatibility. Then we model ex post rationality, and finally we want exactly one outcome to be selected for each pair of reported type and the payments to be non-negative. This is the mod file that we employ to solve the problem in practice. First, we have the two sets of types and outcomes. Then we take utility matrices as parameters, and notice that at this time, since we require dominant strategy incentive compatibility and ex post individual rationality, we don't need distribution over types as a parameter. As variables, we have the outcome selection function and the payment functions. We set a cap of 200 to the maximum possible payment. Then in order, we have the objective function, the two groups of constraints for dominant strategy incentive compatibility, and the two groups of constraints for ex post individual rationality. As a last constraint, we force the outcome function to select exactly one outcome for each pair of types. The .dat file is the same we used in the first lecture on automated mechanism design. Then this is the run file which is needed to run the program. Notice that this time you are dealing with a mixed integer nonlinear program, and therefore we need to employ Baron as the solver. This is the result that we get in this case. The final value of the objective function is 204, and we can see that for outcome 2-1, which corresponds to types high, low, the first player gets the painting and she pays 100. When the reported types are 1-2, so low, high, the same happens but with switched roles. When both players report the same type, the painting is assigned to player 2, who has to pay 2.